In the cold waters off the western coast of Norway, at depths the sun does not reach, sailors and fishermen have for at least 1,000 years described the same animal, a creature larger than any whale, slow, deliberate, and patient, capable of pulling a fishing vessel under without surfacing. The Norse called it hafgufa, sea mist. Later, sailors shortened it. They called it the Kraken. For most of recorded history, the Kraken has been treated as an obvious fiction, the kind of monster that seagoing cultures invent to explain weather and bad luck. But the descriptions are remarkably consistent. The same proportions, the same depth, the same hunting pattern, the same regional waters. And then, in 1873, off the coast of Newfoundland, a body washed ashore. 8 meters of preserved tissue from a creature science had refused to acknowledge. It had a Latin name within months, Architeuthis dux, the giant squid. The Kraken, it turned out, was not entirely fiction. It was the legend of a real animal, told inaccurately. The question is how inaccurately. The earliest written reference appears in Konungs Skuggsja, the King's Mirror, a Norse instructional text composed around 1250 AD. In it, an unnamed Norwegian narrator describes a creature called hafgufa, so large that, when stationary at the surface, it could be mistaken for an island. Sailors, the text warns, have moored to it. 500 years later, the bishop and natural historian Erik Pontoppidan compiled the second volume of his Natural History of Norway. In it, he listed the Kraken among the native fauna of his diocese, with measurements he claimed to have collected from sailors directly. Pontoppidan's account is precise. The animal, he wrote, occasionally rises near the Lofoten archipelago. Its visible mass at the surface measures roughly 1.5 miles in circumference, a figure he himself doubted, attributing exaggeration to the witnesses. But other details remained consistent across his sources. The animal hunted by descending into deep water with its arms extended around it, creating a vortex that drew fish toward its central beak. It surfaced rarely, and when it did, its presence was preceded by a strong, sulfurous odor and a calming of the local sea state. The 1873 Newfoundland specimen confirmed Pontoppidan's smaller relative, the giant squid, Architeuthis dux. It did not confirm the Kraken itself, but it moved the burden of proof. Under the proposed classification, the Kraken is designated Architeuthis pontoppidani, the bishop's Kraken, in honor of its first formal cataloguer. It is the third member of a small clade of confirmed and proposed deep-sea giants. Its closest relatives are Architeuthis dux, the giant squid, and Mythzoology hamiltoni, the colossal squid, both of which were considered legendary themselves until late in the 20th century. It is, by some margin, the largest. Pontoppidan's measurements are unreliable, but careful rereading of the regional accounts suggests a mantle length of 8 to 12 meters and a total length, including the feeding tentacles, of 25 to 40 meters. Some specimens may exceed this. Its habitat is the abyssal plain of the Norwegian Sea, between 500 and 2,000 meters in depth, in waters consistently at or just above freezing. It is a creature of cold, dark, slow places and almost never observed. Its diet is sperm whales, large fish, and other large cephalopods. Sperm whales, it should be noted, are confirmed predators of giant squid. The Architeuthis dux skin, recovered from sperm whale stomachs, is one of the principal sources of evidence we have for the giant squid's existence. Architeuthis pontoppidani reverses that relationship. At its full size, it is the apex predator of its column. Its buoyancy is achieved through a confirmed mechanism. The mantle tissue is saturated with ammonium chloride in solution, a low-density compound that, in sufficient volume, cancels the negative buoyancy of muscle and viscera. The colossal squid uses an identical system. Architeuthis pontoppidani uses it at a vastly greater scale. This means the animal does not need to swim to remain at depth. It hangs, it drifts, it descends and ascends almost passively. Energetically, it is one of the most efficient large predators on the planet, which, combined with its low metabolism and long lifespan of an estimated 80 to 150 years, explains why a creature this large can persist undetected. The arm tips bear bioluminescent photophores. In the abyssal darkness, the kraken extends its arms in a wide spiral above its body and pulses the photophores in a slow, attractive rhythm. Smaller cephalopods and fish move toward the light. The arms close. The eyes of Architeuthis pontoppidani are believed to be the largest in the animal kingdom, larger than those of Mythzoology, themselves the current record holders. They are not for vision in the conventional sense. They are tuned to detect the faint bioluminescent signatures of large prey at distance. At the center of the arms is a chitinous beak hardened with mineralized proteins capable of severing whalebone. It is the only hard tissue in the animal. After death, it is the only part that survives long enough to be recovered. Pontoppidan's witnesses in this light were not lying. They were describing accurately an animal of a scale they had no other vocabulary for. Reproduction is slow. The animals are believed to be solitary outside of brief mating events, with eggs released into the water column to develop pelagically. Most do not reach adulthood. Those that do persist for over a century. The evolutionary history of Architeuthis pontoppidani is part of a wider story, the slow, repeated tendency of the deep ocean to produce giants. 66 million years ago, the extinction event that ended the dinosaurs also ended the ammonites, the dominant shelled cephalopods of the Mesozoic. In their absence, the soft-bodied coleoid cephalopods, ancestors of modern squid and octopuses, expanded into vacated niches. Among them, a deep-water lineage adapted to the cold, lightless, low-resource conditions of the abyss. The Architeuthidae diverged from their relatives during the Eocene between 50 and 40 million years ago, as the deep North Atlantic basins began their final configuration. Architeuthis dux occupies the moderate depths. Mesonychoteuthis hamiltoni, the colossal squid, occupies the cold Antarctic abyss. Architeuthis pontoppidani fills the largest remaining niche, the deep, cold, slow, productive water of the North Atlantic abyssal plain. Each of the three is, by turn, a record holder. Each is rare, slow-growing, and almost never observed. Two are confirmed. The third, by analogy, by signature, and by 1,000 years of Norse account, is the third. In 1997, the United States Navy's Deep Ocean SOSUS array, originally built to detect Soviet submarines, recorded an ultra-low-frequency signal from the South Pacific so loud that it was picked up across 2 ocean basins. It was named the bloop. Its acoustic signature was biological. Years later, it was attributed with some confidence to the calving of an Antarctic ice shelf. In 2003, a New Zealand research vessel hauled in the first complete specimen of Architeuthis hamiltoni. Until that moment, the colossal squid had been known only from beak fragments and the stomach contents of sperm whales. It had been considered by most marine biologists a creature of low confidence. Then it was on a table. Since the early 2000s, deep-water, remotely operated vehicles working the Norwegian abyssal plain have returned a small number of brief, partial contacts with large cephalopods that do not match the recorded morphology of any known species. The contacts are short, the lighting is poor, the footage, in every case, is inconclusive. Sonar signatures from the same region register organisms at lengths exceeding 25 meters. The signatures cannot, with current data, be confidently distinguished from sperm whales. They also cannot be confidently distinguished from something larger. In the fishing villages of the Lofoten coast, the old logs continue. Boats lost without wreckage, calm patches of sea where there should be current, sulphurous notes in the air on still nights. The species has not been captured. No specimen has been obtained. No genome has been sequenced. Two of its closest relatives within the last 150 years have moved from folklore into the scientific record. The third may be next.